Hello everyone, my name is Brown Alamna from Computer Science Department at Debark University. This material belongs to Debark University, so reproduction, distribution, and use of the material without Debark University permission is strictly prohibited. So, welcome to Design and Analysis of Algorithm, Chapter 2. In this chapter, we will learn about very powerful problem-solving technique, which is called divide and conquer. And today we will focus on the general idea of divide and conquer and one important example of binary search. By the end of this lesson, you will be able to understand what divide and conquer means, see how complex problem can be broken into smaller one, apply this idea in binary search, understand why binary search is very efficient. Divide and conquer is a problem-solving strategy. Instead of solving a big problem directly, we divide, which is break the problem into smaller sub-problem, and conquer, solve each sub-problem, usually using recursive, and finally combine the solved problem, merge the solution to get the final answers. Think of it like solving a big assignment. You divide it into parts, solve each part, then combine everything. That is what divide and conquer is. So the subproblem may be smaller, similar to the original problem, and we keep dividing until the problem becomes very simple. When you see the general structures of divide and conquer algorithm, it works just like this. Divide the problem into smaller parts, solve each problem recursively, and finally combine the result. This is the simple pictorial form, or it is a graphical form to represent or to show how the divide and conquer technique works. Okay, here as you see, there is one problem that has n size. After that, we will reduce or we will divide this problem into different subproblems, After that, we will solve each subproblems individually. So that we will put the solution to each subproblem here. We will put the solution for each subproblems. After that, after we solve each subproblems, we are going to combine the problem. We are going to combine the solution into the original problem. It leads to recursive and algorithm. There are some common algorithms that use this technique. For example, binary search, merge sort, and quick sort. Those are a simple example for that use divide and conquer algorithm. Today we will focus on binary search only. So when we see the definitions of binary search is an algorithm used to find an element in a sorted array. Instead of checking every element, binary search divides the array into two halves and check only the middle element. So each time we reduce the problem into half. Let's see this example. From this given array A, let's search the value 33. So the first thing that we should do is create a variable low or low and another variable high. So we need to have three variables. The other variables is mid. we have to get the mid value or the mid index. After giving the low is index 0 and high is n minus 1, which is equal to n minus 1, and low, which is equal to 0. At the first time, we should assign initialize just like this one. After that, we are going to find the index of mid. To find this, the index of mid, which equals low plus high over 2. So 0 plus 14 over 2, which equals 7. So the index of mid will be 7 at index 7. After we get the index, the mid index, we are going to compare the key value and the index of mid, the value at index of mid, which means A of mid, we have to check that if A of mid is equal to key. We have to check that if whether A of mid is equal to key. If this is not true, we have to check whether A of mid is greater than the key or not. Here in this condition, 53 is greater than 33. So we have to move the value of high to high, which is equal to mid minus 1. So we have to move the value of the index of high to mid minus 1 position. We have to move this position because we already know that binary search array should be first sorted. So if the key value is less than the mid value, that means we can find 33 above 53. So we should ignore this element directly. We should ignore this one. So as you see, high is equal to at index 6. After we get the positions of or the index of low and high, we are going to find mid also. Mid is equal to low plus high over 2. That is 0 plus 6, which is equal to 3. So the value of mid will be at this position, or at index 3. Again, we are going to compare the value of mid is equal to the key value or not. If they are not equal, we have to check whether the value at index mid is greater than or equal to 33. So in this case, 33 is greater than A of mid, which means we have to move low equals mid plus 1 position. We have to move the value of low to this position, which means 3 plus 1, that is 4. So the value of low is at index 4. So after we get this, the value of low and high, so again we have to find the mid value. So 4 plus 6 over 2, that is 5. So the mid value is at index 5. After we get the mid value, we have to compare again that the key value, and we have to compare 33 with 43. So obviously 43 is greater than 33, so we have to move the value of high. We have to move the index of high to mid minus 1 position. So the value of mid will be, the value of high will be 4 at index 4. So after we get this, the index of low and high, Well, we have to search the index of mid. So the index of mid is as similar to the index of low and high. So here we will check if the key is not equal to, or the key is equal to the value at the index of mid. So 33 is equal to 33. So here we find the key value, which is at index 4. We found the key value at index 4. So this is how binary search works. So thank you very much for watching. See you later.